Hey, Transmath 2 class, these are your notes for section 2.12. So reviewing in the skills maintenance, it says to write an inequality, an equality or inequality statement for each pair of fractions. So equality means maybe they're equal. Inequality means you're going to do a less than or a greater than. Alright, so for the first one, because they have the same top and bottom number here and here, so 9 over 9 and 2 over 2, we know that those are both equal to 1, so those are equal. Okay, yeah, maybe I'll put it out here, equals. And for this one, 5 over 6 compared to 8 over 6, well, 5 over 6 is less than. 3 over 3 and 10 over 10, again, same idea, those are going to be equal. Go 6 over 7 compared to 1 over 5. Well, 6 is very close to 7. 1 is not very close to 5, so 6 over 7 is greater than. 4 over 4, that's equal to 1, and that is greater than 1/2. Okay, so here we've got some subtracting problems. It looks like each problem, common denominators are already there, so this is pretty straightforward. We just subtract the numerators. So we get 2/3. 4 minus 1 is 3, so we get 3/4. 8/8, 12/10, and 8/9. Okay. All right, so now we're going to make sure that we're doing our common denominators. So if they don't already have that, we need to find those. So first step 1, find a common denominator, and then step 2 is to solve the problem. Okay, so they'll kind of walk us through this. So when you're looking at this problem, 6 and 9, well, if you list all the multiples of 6 here, and then if you list all the multiples of 9 here, what we find for our common number is 18. Okay, and so if you're looking at your multiplication table or something like that, you'll be able to find this is the case. Maybe you can figure that out in your head, like if I were to take, well, 6 times 3, I can get 18, and if I take 9 times 2, I can get 18. Okay, so we need to determine what that common denominator is going to be. Now, finding least common multiple makes it easier to work with fractions. So sometimes there's a common multiple, but it's not the smallest one. If you can find the smallest, then that's the best way to do it. So here, what we're going to do is we're going to take the 5 over 6, and we're going to multiply by that 3 on the top and on the bottom to make an equivalent fraction. And with our 7 over 9, we're going to do the same thing. We're going to multiply by 2 over 2 so that we can get 18 as our denominator again. So we get 14 over 18. Okay, so now we can subtract these two fractions. 15 over 18 minus 14 over 18 would equal 1 over 18. Okay, so here our power concept. We use the least common multiple to find the smallest common denominator of 2 or more fractions. Okay, so that's what we're going to kind of practice right here. So we're going to be multiplying the same thing in these boxes to come up with an equivalent fraction. So how do I get from a 9 to an 18? I have to multiply by 2. And so that would be 18 over 18. So here, how do I get from a 3 to a 12? I have to multiply by 4. So top and bottom, so 4 times 4, 16. How do I get from a 5 to a 20? I have to multiply by 4. Do the same thing top and bottom, 1 times 4 is 4. And here, how do I get from an 8 to a 24? I have to multiply 8 times 3, so 3 over 3. And in the last one, how do I get from a 10 to a 20? I have to multiply it by 2. And so 3 times 2 is 6. Okay, so what's the least common multiple for each pair of numbers? Okay, well, to determine your least common multiple, you just have to think. Many times the least common multiple is going to be the one of the two numbers. If 6 is a multiple of 2, which it is, because I can take 2 times 3 and get 6, well, then my answer is 6. So sometimes it is the bigger of the two numbers. Now, if I look at this one, can I multiply 4 times something and make it 6? No, I can't, because 4 times 2 is 8. So it's not going to be, it's not going to be 6, or it's not going to be one of these two numbers. So then I have to keep thinking, well, if I count by 6's, so if I go 6 plus 6, that gives me 12. Is 4, does 4 go into 12? Is 4 a factor of 12? Yes. Okay, so that tells me, that my answer is going to be 12. So if the biggest number doesn't work here, try doubling that biggest number and then see if the smaller number is a factor of that one, and then that'll be your least. Okay? So here I got 2 and I got 7. Well, you know, 7 isn't a common factor or a multiple of 2. So we could try multiplying them together. So if I double 7 and 14, yeah, 2 goes into 14, so that works, right? 3 and 5, well, 3 times 5 is 15. There's your least common multiple. Is 12 a multiple of 6? Yes, it is, so we can use that one. We can just do 12. So if you're having trouble recognizing, you might have to borrow one of those multiplication tables from me so that you can just look on the table and see, you know, where do I see the common number in each of those lines of multipliers of each of those numbers. Okay, so more practice with finding equivalent fractions here. So I'd have to go 10 times 2 to get 20. So there, I think I might have done these 4 times 5. So we'd get 4, 8 times 3. So this was just making equivalent fractions, which I think we did those already. I already did these, so I'm not going to go through those again. Okay, so here we need to, it says solve by finding the least common multiple. So in these problems, so I have one fraction that has a 10 and one that has a 5. Okay, well I'd have to multiply this one by 2 on the top and bottom. Then I write 7 tenths minus 4 tenths, and 7 minus 4 is 3. So I would get 3 tenths there. Okay. In part B, I got a 3 and I've got a 10. Well, I think I have to multiply by 3 on this one and make a 30 on the bottom, and then multiply by 10 here, make a 30 on the bottom of this one, right? So 10 times 2 on top, that would be 20 over 30. And here I'd have 3 over 30. And when I add these together now, I'll have 20 plus 3, so I'll have 23 over 30 for my answer. Okay. This problem, I'm going to go times 3 here and times 5 here, so that way I can get a least common multiple of 15 on the bottom, right? So first one I have 15 and then I have 10 on top, and on the second one I have 15 on the bottom, and then 2 times 3 is 6. Okay, so common denominators, now I can say 10 plus 6, which is 16 over 15. Okay. All right, problem solving activity. So the scatter plots are a struggling band that needs to find work during the day. They are much better at doing home repair projects than they are at playing music. They're fixing the floor in an old home that they are renovating. So Zach is measuring the wood he needs to fix the floor. The longest board is 1 whole unit, so that's that one. Here's what the rest of the floor looks like. So you got these A, B, C, D, E, and F, okay? So here's the information that Zach has here, okay? So the length of board A is equal to 1/2, so I'm going to put a 1/2 there. B would also have to be 1/2 then, if A is 1/2. C is 1/4, so that equals 1/4. And D is 3/4. E is 2/3. And F is 1/3, and that looks about right. Okay. Now question 1 says how much longer is D than F? Okay, so how much longer? That's going to tell us to subtract. Okay, so we're going to subtract D, which is 3/4, and F, which is 1/3. So we're going to go 3/4 minus 1/3. So now to do this, I need a common denominator. I'm going to get a 12 there, so I'm going to multiply that by 4, this one by 3, and I'm going to rewrite these fractions. So I'm going to have 9/12 minus 4/12. 9 minus 4 is 5. So I get 5/12. Okay. What is the combined length? Okay, combined length, that means to add. Okay, combined length means add. A and C, okay. Well, A is 1/2 and C is 1/4. So 1/2 plus 1/4. Okay, so in order to do that, I need to make a common denominator. I'll multiply by 2, and so I'll have 2/4 plus 1/4. And I'll go back to blue, sorry. 2/4 plus 1/4, and that's going to be 2 plus 1, which is 3, so we get 3/4. Okay, Zach thinks that if he puts board A and board F together, he will get a fraction greater than 1. What is the combined length? So combined length, again, that means to add of board A and board F. Okay, so board A, I think, was 1/2, right? A is 1/2. F is 1/3. So 1/2 plus 1/3. Okay, well, I guess they had it here. So 1/2 plus 1/3. Okay, so to do this, I'm going to get a common denominator of 6 if I multiply by 3/3 and by 2/2. Then I will have 3/6 plus 2/6, which equals 5/6. Now, the question was, is the combined length greater than 1 whole? Well, 5/6, no, because 5 is less than 6. So no, not greater than 1 whole, right? It's less than. So 5/6, answer to that question is no. Zach knows something about equivalent fractions. He knows that 1/2 equals 2/4, 1/2 equals 3/6, 1/2 equals 4/8, equals 5/10, and equals 6/12. He needs to fix a spot on the floor that's 1/2 unit in length. What board or boards could he use to equal a length of 1/2? Okay. So what we want to know is which of these boards is equivalent to 1/2. Okay. Well, we know that A and B are 1/2. And I guess, are they asking us if we were to add some boards together, could I get, I suppose we could use A or B, and we could use 2 C's. We could go C plus C. Let's see what else. Okay, so you could use A, B, or 2 C's. Looks like what I would use for those. So that is it. That's all for your